Hello again. In this video I am going to teach displacement. Previously you remember we mentioned about speed and the velocity. The formula of speed equal to displacement out of time. Now we are going to mention displacement. Displacement is defined as distance moved in specified direction, so that displacement is vectorial quantity, which make velocity is vectorial. For example, if body moves along a straight line in a given direction, such as 100 meter due east or 50 meter due north. Here, due east shows direction and due north shows direction, so that 100 meter due east or 50 meter due north make it displacement. Just 100 meter is distance, which is not vectorial, or 50 meter just is distance. This unit shows length. And here delta x shows displacement, and displacement equal to final position minus initial position. Final position, as you see, it is about 85 meter, minus initial position, it is about 25 meter, so that displacement equal to 60 meter. Yes, we can continue with time graph with displacement. Let us say here is displacement, here is time. Let us talk about the object of k again. Displacement here is constant, as you see. So speed of object is 0 because object does not move. Displacement remain constant. Between this time interval, displacement is constant, velocity must be 0. Let us look at another object, let us call it L, and graph is displacement versus time. With time, displacement is increasing, constantly increasing, so that here there is velocity because object is moving. At the beginning, object is constant, then it moves 1 meter, 2 meter, 3 meter, and 4 meter, let's say. Then another displacement time graph. Here, object moves in opposite direction because it takes some road. Let us say here is 0. It is somewhere here. Let's say x final and x initial. It is somewhere here, x position, and it goes in opposite direction, and it came to beginning point, 0 point, so that it shows that it moves with minus velocity. Yes, we can continue with displacement time graph. As you see here, again, we can call it delta x and t. This graph shows that it starts to move, but then slow down and remain constant. So here, for, let's say again, this is object k. If we need to draw velocity time graph, what happens? It moves with decreasing velocity. Why? Because it takes some road, then it stops. When it comes here, t1, it stops. And again, we can mention about another graph. Let us call this is L. And if we need to again mention about velocity time graph for object L. This is object K. Here it moves with minus velocity in opposite direction. It comes again time interval 0 t1 time interval. It moves in opposite direction, then it stops again, because when it reach here, as you see at time here, displacement become 0. It does not move anymore, as you see. So that for object K, velocity time graph, at the beginning it has some velocity, but then it stops. Here again it moves in negative opposite direction and it stops after a while. We can continue with displacement time graph. As you see here, displacement is increasing, so that if we need to draw velocity time graph, it moves with increasing speed, because let us give number time in second, velocity in meter per second. When time is 1, it takes 10 meter. When time becomes 2 seconds, it takes 2 meter, 20 meter. So that if we need to draw it, at the beginning object is constant. In 1 second, it takes 10 meter. 1 second more, it takes 20 meter. So 1 second more, it takes 30 meter. Here you see taken distance increasing much more than time. For this, I say again, this is object K, this is object L. For object L, same, but object L, this is object K, object L moves in opposite direction with increasing speed. Object K and object L moves with increasing speed, but object K goes in positive direction, object L goes in negative direction, so that object K and object L goes in opposite direction for each other, because here in positive direction, let us say delta x plus, and L goes in minus delta x direction. At the beginning they were together, but after time t, 0 t time interval, the distance between K and L becomes 2 delta x, as you see. So let us continue with more graph. Here, as you see, distance increasing constantly. Distance increasing constantly. The line rise 10 meter on the scale for every 1 second on time scale. Here it means if we need to draw speed and time graph, it is steady speed. Here it moves with higher speed steady. 0 time distance 0. In 1 second it moves 20 meter. In 2 seconds it moves 40 meter. In 3 seconds it moves 60 seconds. So that gradient is constant, so that speed is constant. In A and in B, car moves with constant speed. But let us look at graph C. In graph C, you see speed distance increasing. Here time is 0, distance is 0, time is 1, distance is 10. If speed is constant, when we come time 2, speed must be 20, but as you see, speed here is 25, so that car is accelerating. Means it moves with increasing speed. Here, distance is constant. It does not go further or back, so that in time 0 or 1, 2, 3, 4, 5, time goes on, but distance is constant. So car stopped means velocity is 0 meter per second here. So we finished displacement, and next topic we will continue motion.